Okay, welcome you guys to my new tutorial about equations in general, and in this video I will talk about a very special theorem, and it's called Vieta's theorem. Vieta was a French mathematician. Do not mix him up with Vegeta from Dragon Ball Z. These are not the same persons, okay? So let's start off. What is Vieta's theorem and where does it start? Okay, the idea is that if you take the general form of a quadratic equation divided with a leading coefficient, which I call the quadratic coefficient, you get, and here is an important statement, that a should not be equal to 0, or this would be 0 and we would get only a linear equation. So we divide with a, we get a over a, which is equal to 1. We get b over a, which is this, and we get c over a. Now you can use some kind of substitution, and you say, as we divide b with a, this will give you some number. We will call it number p. And c over q will give you another number. Very important that we don't divide with 0. There are some special numbers, and this will give you q, and this is equal to 0. Now if you use the general solution, you will get something like this. You get x1 2 is equal to minus p plus minus, so minus p is this which we call b in our general formula, plus minus the square root of b squared, which is p squared, minus 4 times a times c, but c is q and there's a 1 here, and this is over 2 times a, while a is equal to 1. Now you can do something with that solution, and actually if you add up both solutions, so x1, which is this but with a plus, and x2 is with a minus, if you add both solutions you will get minus p. So rewritten here, if you add them and change the sign of that, of the sum of them, you will get p. P is actually this coefficient. And another point is, if you multiply both solutions, you will get q. x1 times x2 will give you q, which is this number. Okay, how did Vieta come to do this? It's not very normal to really add these solutions or multiply them. He came to this place with another way. He just started off with a solution looking like this. He multiplied this out and came to the solution after dividing with a. He saw that this solution, if you just multiply this out, you will get x squared minus x1x. Then you multiply this with this, you get minus x2x plus x1 x2, and actually you see x1 x2 will give you the constant term, and minus x1 plus x2 are the coefficients of the linear terms, and this is what is called p here. Okay, now this looks a little bit abstract, and actually I must say that Vieta's theorem is not only valid to quadratic equations, but even to higher orders. But I will not cover this topic in this lectures. I will come back to this topic and maybe in later lectures, because I don't think it's really important to solve cubic equations and so forth with using this kind of stuff. Okay, so now let's have a look at our first example. Examples are always very important, and you should know what we want to do. Okay, we have this equation, x squared minus x minus 2 is equal to 0. Okay, you see we have a quadratic equation, so one variable is to the second power, and we have it's also x here. So what you could do is just use and slam on this with a general formula. Okay, this would give you a valid solution, but if you are a little bit lazy and you want to guess the solutions, you can do this by using Vieta's theorem. What Vieta stated was that this coefficient here, which is actually -1, will be the negative of the sum of both solutions, as well as this part -2 will be the product of both solutions. Okay, now which one is the important one? And I always start off with the product. Okay, why the product? If you say that the product, or better, the solutions are integer numbers, so for example 1, -1, 2, -2, and so forth, so all integer numbers, you can just try to find the prime number factorization for this. And then it's not actually the prime number factorization, but a factorization which can also have a ±1, okay, in it. Now we start off, and how can we rewrite this? We can rewrite this by saying this is ±1, okay, times minus plus. So I did this in general, but just, okay, let's start off with -1. If you have -1 as x1, then you can have here 2. If you have +1, you will have to have here -2. Are there any other ways to write -2 as a product? I guess there are other kinds of representations, but they are not integer numbers. Okay, so now as we guess this, now you can look up which solution really, so this is easy to do, so -1 and 2. Now look up -1 and 2, does this also do this? So -1 plus 2 will give you +1, and -1, actually this is solving. So -1 and 2 is a pair that solves the solution. Now let's try the other pair, +1 minus 2. If we would set this in, +1 minus 2 would give you in the brackets -1, but -1 would give you 1. So this doesn't work. There is actually only one solution, a pair of solutions. Now we have found the first solution and the second. Now what can we do? We can rewrite this equation above, which we started with, was x squared minus x minus 2, and we can rewrite this as 1 times, I'm using this 1 all the time because you have to remember that these equations only are, for example, if we had here 2x, then you had here something with 2, okay? So it's important to put the 1 to show that you know there has to be the quadratic coefficient. Then you open the bracket x minus your first solution, which is 2, and then you have x minus 1, which is actually give you x plus 1. Okay, so you can rewrite this quadratic equation to this. Okay, why is this important? This is, for example, important if you want to divide this equation with something special, for example x minus 2. Okay, if you had this and you would divide it with x minus 2, you would not see how you can divide it. By factorizing this in that manner, it's easy to see that you will only be left with x plus 1. Okay, very important. Okay, now I hope you got it, but if you still don't know actually what's the idea about it, keep cool, because we are going to do some more examples. So I think there are 7 examples in total. Now let's start with the next quadratic equation. Okay, x squared plus 3x minus 4 equals 0. Okay, you can see this. Now what do we actually do here? First of all, you see that the quadratic coefficient is 1. Remember that, we will need that later on. Now let's try to look for the coefficient. So we have here plus 3, and we know this has to be the negative of the sum of the solutions. Okay, and we know that the minus 4 has to be the product of both the solutions. Now what do we do? First of all, look at the product, the minus 4, so your constant number, if it's already divided with a, very important, you have to have a normalized quadratic equation with a 1 in front. But if you have done this, the constant part has to be the product of both solutions, okay? And if you assume that the solutions are integer solutions, you can rewrite the -4 in some special ways, okay? You could rewrite this as plus minus 1 multiplied with, I have rewritten this wrong because I thought that in the general sense, but actually minus plus 4 would be the right way to write it. And this would be a pair of solutions that you could use, or plus minus 2 times minus plus 2. So this is actually now right written. Now let's just check which is the right solution. Let's start off with a plus 2 minus 2 solution. So this actually solves this. Now let's look if this is solving that. If you have plus 2 minus 2, this will give you 0, and the minus 2 plus 2 will give you the same. So these this pair of solution is a very bad pair of solutions. Now let's look at this. Plus 1 and minus 4. Plus 1 minus 4 will give you minus 3, minus 3 will give you plus 3. So this would solve our problem. The other solution would be minus 1 plus 4, which would give you 3, and minus 3. This would not be the right solution. So our pair of solutions is this actually. It's x1 equals to minus 4 and x2 equals to 1. Very important. Sometimes my pupils say, why isn't it x1 equals 1 and x2 is equal to minus 4? This doesn't matter how you call this, because it's a symmetric equation. So you could switch positions of x1 and x2 as well as here, and you would get same results. It doesn't matter how you call your solution, it's only important that you have the right solution. So this is the right pair, and then we rewrite this as a factorization, or how it's called in English. So you have 1 multiplied x minus minus 4, because this is minus this solution, which is minus 4, multiplied with x minus 1, because this is the solution, okay? This should be equal to this, what we started off. And again, remember, this is very important if you want to divide with something like this, okay? Now let's go on. Now, next example. Our examples are pretty fast and pretty short here. We have x squared plus 5x minus 6. We first realized that this is a normalized equation. You could use the general solution formula, but we don't. We see that plus 5, which is this, has to be the negative of the sum of both solutions. This is the theorem of Vieta, and the constant part has to be the product. Now just remember how you can rewrite the product. It's minus 6 can be written as plus 1 times minus 6, or minus 1 times 6, or you can rewrite it as plus 2 times minus 3, or minus 2 times plus 3. Just put in your solutions, and as you get to your first solution, you have done it right, okay? For example, let's just test the right solution, minus 6 and plus 1. This is trivially because we generated our pair of solutions, or guess solutions like this. Now, minus 6 plus 1 will give you in total minus 5, but minus 5 will give you plus 5. So this is the pair that solves this equation, and we can rewrite the starting point as 1, because this is the quadratic coefficient, x minus 6, which will give you plus 6, multiplied with x minus 1, which will give you x squared plus 5 minus 6, okay? Now, you see, this is a very, very similar way what we do all the time, and you just have to remember this steps, okay? Now we have another equation, which is x squared plus 4x minus 21 equals 0, okay? Now you have as p is 4 plus 4, very important, and this has to be equal to the minus, so the negative of the sum of both solutions, and minus 21 is equal to x1 times x2. Now rewrite 21 you can write it as plus minus 1 multiplied with minus plus 21, but this actually doesn't solve this, because if you would add them, this would be a very large number, and that could never be 4. So, and the other solution is plus minus 3 multiplied with minus plus 7. So let's take plus 3 minus 7, check this in here, plus 7 plus 3 minus 7 will give you minus 4, minus 4 will give you plus 4. So this is solving this. So our pair of solutions is x is equal to minus 7, and this here x is equal to 3. Okay, I hope you can read it. I think I want to go back here a bit because the focus was not that good, but I'll just continue. Okay, now you have the solutions, just enter them in. 1 times, because the quadratic coefficient is 1, multiplied x plus 7, because it's minus 7, which will give you plus 7 here, and x minus 3. So how you could check this, if you would plug in this 3, it should give you, if you plug in the solution, it should give you a 0 here. For example, minus 7 plus 7 will give you a 0. Okay, and actually if you multiply this out, you will get this. Now let's continue, and now maybe you start to think, wow, this is even cooler than using the general formula, and actually this is pretty cool. I must say this is pretty cool, but you cannot solve any kind of equations, and we will look at one that you can actually not that easily solve, but if you have a good eye, you can solve it actually. Now let's have a look at this. It's x squared minus 10 third x plus 1 equals to 0. Okay, first of all, what you could say, this is not looking as if our solutions, we have here 10 over 3, it's not looking like the sum of our solutions, because this shall be the sum of our solutions. If you take only integer numbers, you won't get there, so you have to have some fractions in it, or other terms. I don't know what you could have, but actually fractions would do the job. Okay, now if you look at this, you see 1 is equal to x1 times x2, so if you multiply it, you get 1 out. If you put x2 to the right hand side, you see that x1 over x2 is equal, 1 over x2 is equal to 1. This means that the solutions are reciprocally connected to each other. Okay, now you could just try out values. For example, 1 plus 1 over 1 would just give you 2. 2 plus 1 over 2 would give you what? What would this give you? This would give you nothing better. It would give you 2 plus a half, so 2.5, or written other ways, 5 over 2. Now if you hit 3, you get 3 plus 1 over 3, but this is, you have a fraction here. 3 is, if you bring in same denominators, you have 9 over 3 plus 1 over 3, you get 10 over 3, and minus 10 over 3. So actually this would be a legit solution, and actually this is the solution, 3 and 1 over 3. If you plug them in here, I was tending to say Vegeta's theorem, but it's Vieta's theorem. So 1 times, we open the bracket, x minus 3, close the bracket, x minus 1 over 3. You could just multiply this out, you get your x squared, which is actually right. You get minus 3x minus 1 over 3x, which will give you minus, which will add up to minus 10 over 3x. And as the last term, as the constant term, you get minus 3 multiplied with minus 1 over 3, which will give you just a plus 1. Okay, now, okay, we saw that it is even possible to solve with fractions, but it's getting harder, and it needs a bit of work to understand how to solve them. Now, this is a solution that you should not be able to solve by normal ways, but let's just look at it. If we could solve it actually, but it's very hard to understand. Okay, so I'm just doing this as an example, that you know that sometimes it's not possible to find the solutions, then rather use the general formula. Okay, if you look at this is minus 2, which is our p, which has to be equal to the negative of x1 plus x2, and minus 1 has to be equal to the product of x1 x2. Now one could say, okay, let's try fractions again. So some fraction times the other fraction, you could do that and you will get no result. So this is just as it is, and I constructed this example but just going from this way to that way. Okay, I didn't find this on my own. I could have used the general formula, okay, but I constructed this that you get these solutions. X1 is 1 plus square root of 2, and x2 is equal to 1 minus the square root of 2. If you want to check, just put them in and you see that this is actually true what I've written down. This is true because you have 1 plus square root of 2, and then you add 1 and subtract the square root of 2, so you get minus 2. So this is true, and multiplying this with this, you can use the third binomial formula, so you get 1 squared minus 2 squared, which will give you 1. Okay, this was a hard example, and now let's come to the last example I figured out that should be also mentioned in this video. It's very general. It's 2x squared minus 8x plus 8. Now what I do is first I want to divide with 2, because we only want to look at normalized solutions. Okay, we divide with 2, sorry, and we remember that the quadratic coefficient is 2. Okay, now after dividing with 2, we get a new equation, which is looking like x squared minus 4x plus 4. Please, this is a 2. I've written it in another strange way, so it looks more artistic, but now I see it's very, very disturbing. Okay, now let's look at the coefficients. This p has to be equal the negative of the sum of the solutions, just write it down, and this 4 has to be the product of both solutions. Now let's look how we can rewrite 4 as a product of integer numbers. Okay, now we have here plus 1 minus 1 multiplied with plus minus 2 equals plus minus 2 multiplied plus minus 2. So there are two kinds of solution, and just hitting plus 4 and plus 1 here, you get 5. Minus 5 was not sufficient to solve this equation. Minus 4 and minus 1 will give you the same problem, because you will get minus 4 is equal to plus 5, which doesn't solve, but plus 2 and plus 2, which gives you right solution here, so the pair of solutions is 2. Okay, but now it's something strange is happening. People mix this up and say, well, x1 is equal to 2, x2 is equal to 2, so we only have one solution, it's x1 equals to 2. But now we have two solutions which are equal. This is the case where the determinant is equal to 0. Okay, in the general formula, just revisit the video for the general quadratic equation, and you will see that the determinant, which you can calculate here by b squared minus 4 times a times c, which will just give you a 0 determinant, and with this a 0 square root, which will just be eliminated. Okay, now if you have this, rewrite this as a product. We have the quadratic coefficient. Now the first time where I actually used this was the 2, okay, because we started off here, 2 times multiplied with x minus 2, because this is the first solution, multiplied with x minus 2, the second solution, is equal to x squared, 2x squared minus 8x plus 8. Okay, I hope you got the idea. What is Vieta's theorem? It's very important to fast solve solutions. If you have some feeling for it, you can very, very fast find integer solutions and spare a lot of time for you and make less mistakes in calculating, because you can just cross-check this by multiplying out if the solutions are right. Okay, just remember, take the most crucial part was always to look at the 4, then to divide it in integer products of with two parts, and then just hitting them in the plus condition of the solutions, and you should see if this is true. If you find one solution, that is the pair that is very important. Sometimes you might end up in some equations that are not solvable. This is the case where the determinant is less than 0, which will give you a negative square root, which cannot be solved in the real domain. So I hope you liked my video and I could teach you something more. I hope the HD did help you to see things much more clearly here, and I hope you just had fun on this. Okay, thank you a lot and see you again.